Hello and welcome to another video by www.electricalpereview.com. In this video, we're going to be exploring three-phase transformer connections. So if you look below, you can see four sets of three single-phase transformers apiece. And on top, you can see delta delta, delta Y, Y delta, and YY. If you had to guess, I bet you could probably tell that with these blank templates, we're going to use our three individual single-phase transformers to draw out each of the four different possible three-phase connections using delta and Y. We're going to do our deltas in blue and our Y's in orange so it's easy to tell between the two. And then we're going to draw out the different equations for our voltages and our currents down below. Ready? Let's begin. Here's our A line. Next is our B line. And last is our C line, all on the source, delta. Now we've got to connect these so that they form a delta. So we bring this down right here, and we tie in our A to our B. We bring this leg down here, and we tie our B to our C right here. And now we tie it all in together by tying in our C with our A up top. If you follow the path, we've got our A phase connected to B phase, connected to C phase, connected back to A phase, completing the triangle of our delta. Here we've got our A line current for our delta, our B line current, and our C line current. Here we've got our phase current, IA to B. Here's our phase current, IB to C. And our last phase current, IC to A. Using Kirchhoff's current loops, we can solve for our line currents. Following the path up top, we've got IA is going to equal to IAB minus ICA coming up top here. So we've got IA equals IAB minus ICA. Next for IB, we've got IB is going to equal phase current IBC minus IAB coming in on top. So IB is going to equal IBC minus IAB. And last, we're going to have, if we follow the diagram, we've got IC entering is going to equal ICA leaving minus IBC entering. So we've got IC is going to equal ICA minus IBC. Now, what about for our voltages? Well, since it's a delta, we know our line voltages are going to equal our phasor voltages. So we've got up top plus VAB minus plus VBC minus, and then from A to B we're going to have, and then from C to A we're going to have plus VCA, and then this minus is actually going to be all the way on top here to this A node. Same thing with our load side. We're going to tie in our first and second transformer here. We're going to tie in our second transformer with our third transformer here. Here's our A load line. Here's our B load line. And here's our C load line. And last, we know we've got to tie in our A to our C to finish the delta. So right up here, we're going to tie in our A to our C. Here's our load line current, I capital A. Our load line current, I capital B. Our load line current, I capital C. Here's our polarity mark, so we know if we've got our IAB phase current flowing into this dot, then our IBA current is going to be flowing out of that dot. Notice we're going to use our convention of IB to A because we're flowing from node B to A. So just like down here, we're going to be flowing out of that dot. And this is going to be our I capital C to capital B. And here's our last phase current for C. It's going to be flowing from A up top on this line, I capital A into C. So we're going to just draw these up here because we're short on space. So for our load, notice we're using capital letters for our load and lowercase letters for our source. We've got IA leaving the node is going to be equal to IBA entering the node minus IAC leaving the node down here. So we've got IA on our load side, our load line current is going to equal to I capital BA minus I capital AC. Next for our load line current IB, we're going to have IB leaving the node is equal to ICB entering the node minus IBA leaving the load. So we've got IB equals I capital CB minus I capital BA. Last, we've got our load line current C leaving the node is going to equal to IAC phase current entering the node minus phase current ICB leaving the node. So load line current IC equals load phase current IAC entering the node minus load phase current ICB leaving the node. And just like for our source, since our load's a delta, our phase voltage is going to equal our line voltage, which is going to be plus V.A.B. minus. For phase B, plus V.B.C. minus. And then plus, for phase C, V.C.A. minus. Pay attention to our notation. C to A, voltage and currents, they're always going to show you the direction they're being measured across or flowing through. And this minus right here is actually tying into A up here. So our VCA is going to be plus at C and minus to A. Okay, moving on to the next example. Just like before with our delta, here's our A. Here's our B. And here's our C, lowercase because it's the source. We tie in our first and second transformers here and here. We tie in our second and third transformers here and here. And to complete the delta, we tie in C all the way up to A, right here. I'm going to pass on drawing in our line currents, since it's going to be the exact same as in example 1. So this right here and this right here is going to apply to this same source delta. Instead, we're going to move on to our load Y. So for our load Y, we're going to have all three phases are going to be connected together at this center point, the star point. So let's make that star point right here. We're going to tie in the bottoms of our first, second, and third transformer right here, here, and here. Now that all three phases are tied in at the center, we're going to draw out our load A line, our load B line, and last, our load C line. Now, since current flowing in the dot for polarity is going to be the same as current flowing out of the dot for our load, here's our load line current A, our load line current B, and our load line current C. We're drawing it this way to show that this right here is not a connection here and here. Our connections are only being shown as dots. So if I were to draw it here, it would be the same thing as exiting the node. Now, we know that since we've got a Y, our phase currents are going to equal our line currents. However, our phase voltages are going to be different than our line voltages. So let's draw those out so we can visualize them. First, right here, you'll notice our center tap point is our neutral. So we can come off anywhere along this line, call it our neutral. So we're going to have our A line voltage, or plus V.A.B. minus our B line voltage, or plus V.B.A. minus our C line voltage would be plus V.C.A. minus, and then all of our phase voltages, we're just going to draw C because we're low on space, would be starting with the polarity at the node it's coming from, so VC, and then negative at N, the neutral. Next up, for our third example, we're going to draw our Y source. First thing, let's make that star point in the center connection. So we're going to tie in our first transformer, our second transformer, and our third transformer all together on the bottom legs. Here's our neutral for our phase voltages. Here's our A line source, B line source, C line source. Here's our source line current A, our source line current B, our source line current C. Since it is a Y, there is no difference between line or phase current. We've got our line voltage for the source for A as plus V lowercase AB minus, lowercase because it's the source. We've got our line voltage for B as plus V lowercase B to C minus. And then for C, we're going to have plus VCA minus up top. Notice our currents are flowing into the transformers because it's the source. For the load, they're always going to be flowing out. And again, phase voltages would be plus VC, the phase they're coming from, to N, the neutral, and minus. And again, since this is a Y, our line-to-line voltages are not going to equal our phase voltages. But our line currents are going to equal our phase currents. Okay, let's move on to our load delta. Just like this example right here, we're going to tie in our first transformer with our second transformer, our second transformer with our third transformer. We're going to tie in our first transformer with our third transformer right here to complete the delta. Here's our load line, capital A, capital for the load. Our load line, capital B. And our last load line right here, capital C. Here's our line currents, leaving the delta since it's the load. Line current A, line current B, line current C. We're going to draw our phase currents. We're leaving the dot since this is our node polarity for our load. Up top here, because we're going from B to A, is phase current BA. Again, capital because it's a load. Our second phase, we're going from line C to B. So this phase current is ICB. And last, we're coming all the way up top here from A, going all the way into the winding of this third transformer into C. So our last phase current is going to be capital A to C. And if we write out our equations for our line currents equaling our phase currents, they should be equal to what we found up top here, since they're both delta loads. Let's find out if that's the case. So our line current A for a load is going to equal phase current IBA entering the load minus phase current CA leaving the node. So IA is going to equal to IBA minus IAC. For load line current IB, we're going to have IB is going to equal our phase current ICB entering the node minus our phase current IV.A. leaving the node. So IB is going to equal ICB entering the node minus IV.A. leaving the node. Last, load line current C is going to equal our phase current IAC entering our node minus our phase current CB leaving the node. So load line current IC is going to equal IAC entering minus ICB leaving. And if we look up here, they're exactly the same, so we know our math is right. This is for our load currents. And since it's a delta, our phase voltages are going to equal our line voltages. And that's going to be plus V.A.B. minus plus V.B.C. minus plus V.C.A. and this minus is all the way up top at this A. Okay, last one, our Y source to our Y load. Let's connect the bottom leg of each transformer to form our star or Y point right here. Let's show both of our neutrals right here for the load and here for the source. Here's our source line A, lowercase for the source line B, source line C, load line capital A for the load, capital B, capital C. And since we know all of our source and load currents, because we did them here for a load Y and a source Y, I'm going to do a little bit better job at showing the voltages. So right here would be plus, we're going to do it in red this time so it stands out. VAB minus is our load line-to-line voltage between A and B, plus VBC minus our line-to-line load voltage for B to C. And then here, I'm going to draw a dashed line. We're going to have plus VCA, since we're going from node C to node A, minus, so we've got plus VCA minus is our C line voltage, or our line-to-line voltage from C to A, as it's sometimes called. Here's our phase voltage for C, plus VC neutral minus. Here's it for B. We've got plus. We're measuring from our line B to neutral, minus. And then for A, we've got plus VBN, VAN minus. So there we have it. It's a little crammed, but I hope this is a great demonstration. We've got a delta-delta three-phase transformer, delta-Y three-phase transformer, a Y-delta three-phase transformer, and a Y-Y three-phase transformer, all made up using just regular, ordinary three single-phase transformers. Key things to remember are your polarity. Anytime you have a polarity dot, like here, on the source side, it means your current is flowing in. Now, on the load side, it means your current is going to be flowing out. It also sets your polarity for your voltage. The dot is going to be where your positive voltage reference is. The minus is going to be where there's no dot. So on this case, this would be our plus VBA. And on our load side, here's where our plus VAB minus would be. Anytime you're dealing with Y, you're always going to connect the legs of all three transformers to make your Y point right here in the center. And that's also where your neutral is going to come off of. can be shown down here, up here, really anywhere as long as it ties into this neutral bar. And for the delta, to make up all three sides of that triangle, you're going to start at one line. You're going to go through a transformer, end up on your next line, go through a transformer again, end up on your third line, and you're going to tie it all the way back into your original line. Okay, that's it for this episode. We certainly hope you enjoyed. For more sample problems in our premium review course, please visit us at www.electricalpereview.com.